inclusion exclusion principle. So let A and B be any finite set. We use the notation NA and NB to indicate the number of elements. So the principle says that number of element of A union B is equal to number of element in A plus number of element in B minus with number of element in A intersection B. Principle name inclusion exclusion. We include these two sets and then we exclude this part. So first we include and then we exclude. So that's why we call it as inclusion exclusion principle. Why we have to exclude this? Because when we add these two, we already have counted the elements twice. This intersection part, we have counted it twice, so that's why we have to remove here. So this principle holds for any number of sets. Okay, similarly, for three sets, okay, let A, B, and C be any finite set. We have number of element in A union B union C. Okay, let's say this is A, this is your A. Look at the Venn diagram. B and C. Okay, we have A, B, and C. So first add the number of element for each set. Number of element in A here. Okay, and add number of element in B and add number of element in C. And then you have to exclude or subtract number of element in the intersection part here. A intersection B, and then A intersection C, and B intersection C. And the last one, you have to add back a number of element in A intersection B, intersection C. Yeah. Okay, let's look at this example. In group of 37 customers, 30 drink latte, 14 drink mocha, and 5 drink neither. Find the number of customer who drinks A, both latte and mocha, B, only latte, and C, only mocha. Let L and N denote the set of customers drink latte and mocha respectively. Both latte and mocha means the intersection part. So you want to find number of element of L intersection M from the inclusion exclusion principle. And L union M and L plus and M minus with number of element latte intersection mocha. Now you want to find this one, right? So we need to rearrange this formula. So you will have number of element L intersection M is equal to number of element in L, number of element in M minus with number of element L union M. You know from the question, NL is equal to 30, number of element of M is equal to 14, and number of element L union M is equal to 37 minus 5. Let's draw the Venn diagram of this problem. The universal set here. Then you have two sets, L and M. This is L, This is M. So the total is 37. And you have 5 food drink needles. So the 5 must be here, outside the circle. So now let's solve this problem. 30 plus 14 minus with 37 minus 5. So you will get 12. So L intersection M must be 12. Question B, only latte. Only latte means this part. Only latte here, this part. Okay. Number of element of, so L minus M is equal to number of element in L minus number of element L intersection M. So number of element L, 30 minus 12. Okay. So the answer will be 18. Okay. So this part is equal to 18. And then question C, number of element of M minus L. So similarly, number of element in M minus number of element in L intersection M. So you will get 14 minus 12 equal to 2. So this part will be 2. So when you sum up all this, 18 plus 12 plus 2 plus 5, you will get this value, 37. Example 2. A survey of a group of people was taken in X dental clinic. The results were 43 came for consultation, 36 came for whitening treatment, 19 came for scaling, 16 came for consultation and whitening treatment, 7 came for whitening treatment and scaling, 5 came for consultation and scaling, 2 came for consultation, whitening and scaling, and 10 just came to accompany their family. So this is all the information. Now the question asks you to draw a Venn diagram that represent the result of the survey. Okay, first you have to take out all the information in the simpler form. Let consultation, whitening treatment, and scaling denote as CW and F respectively. So you know that number of element of C is equal to 43. Number of element of W equal to 36. Number of element of scaling is equal to 19. And then number of element of C intersection W is W intersection S. And then we have C intersection S. Okay, take out all the information. This one 16, 7 and 5. And then 2 came for consultation, whitening and scaling. Okay, consultation, intersection with whitening, intersection with scaling is equal to 2%. And 10 must be outside the of these 3 sets. So now you have all this information. The question asks you to draw a Venn diagram. First, you have to draw a big
rectangle.
and then 3 overlapping circles must be located inside the rectangle. Okay, so this is the universal set, and then label it as C, W, and S. Okay, so this is the information. Okay, so outside the three circle must be 10. So first, look at these 3 overlapping circles. So there will be 8 different regions. So this is region 1, region 2, region 3, region 4, region 5, region 6, region 7, and region 8. How do you find this region? Okay, it is from 2 power of number of set. So 2 power of 3, so you will get 8. Let's say you have 2 set here. So 2 power of 2, you get 4 region. So this is region 1, region 2, region 3, and region 4. So now fill in the Venn diagram. Start with 2. 2 belongs to all 3 sets. It's the intersection of C, W, and S. So 2 should be here. And then we have 5 here. 5 is the value of C intersection S. 5 minus 2, you will get 3. C intersection S, so here will be 3. So 3 plus 2, you will get this value of 5. And then 7, this 7 is W intersection S here. This part will be 7. So 7 minus 2 goes to 5. So this part will be 5. And then 16. 16 minus 2 will be 14. 14 is intersection C and W. So this one must be 14. Okay, now number of element in S. Okay, this is your S. This is S. So 19 minus 3 minus 2 minus 5, you will get 9. Similarly to W, 36 minus 14 minus 2 minus 5 is equal to 15. And the last one, 43 minus 14 minus 2 minus 3, you will get 24. So here will be 24. And last one, 10 belong to none of the 3 set. Okay, so now you get your Venn diagram. With question number 2, find number of element in C union W union S. Here. And question B, number of element C union W union S. Okay, to find this, okay, first one is just by sum up all these elements. Okay, sum up all these value. Number 1, C union W union S is equal to 24 plus 14 plus 15 plus 3 plus 2 plus 5 plus 9. You will get 72. You also can use the inclusion exclusion principle. Okay, if you still remember, so number of element C plus number of element W plus number of element S minus with the intersection C intersect W, C intersect S minus W intersect S, and then plus C intersect S. Okay, this is the inclusion exclusion principle. We just take the value from this part that we write down information from the question. So NC 43 plus 36 plus 19 minus 16 minus 5 minus 7 plus 2. 72. More example. Okay, calculate the number of students who like football but not tennis. Okay, first let's denote it. Okay, F for football and T for tennis. Okay, the Venn diagram. F and T. So you have total 108. 60 like football. Okay. So number of element of F is equal to 60. Number of element of T is equal to 53 and 10 like leader. So 10 must be outside the circle. So now calculate the number of students who like football but not tennis. So you have to find the area here. Football, only like football but not tennis. Okay. Find number of element of F minus T. Okay. F minus T is equal to number of element of F minus number of element F intersection T. So now you have to find F intersection T. So this is your inclusion exclusion principle. F union T is equal to number of element F plus number of element T minus number of element F intersection T. Okay. So rearrange this, you will get F intersection T is equal to number of element F plus number of element T minus number of element F union T. Okay, number of F equal to 60. Number of element in T, 53. Number of element F union T is equal to 108 minus 10. Okay, 10 is outside the circle. So you will get 60 plus 53 minus 98. So the answer will be 15. So number of element in F, 60 minus the intersection that you get just now, 15. So the answer will be 45. Okay, let's see another example. Question number 5. The Venn diagram below shows the number of elements in 3 sets P, Q, and R. If P union Q union R is equal to 93, okay, calculate X. So now you have this Venn diagram. And another information that you have is this 93, right? For A. And number of element in P union Q union R. This is equal to 93. Okay. And this is also the value of the summation of all this value, right? This all from each region in this Venn diagram. So 93 is equal to 10 plus X plus 15 minus X plus 13 plus X plus X plus 10 minus X plus 12 minus X plus 28 plus X. simplify this, you will get 93 is equal to 25 plus x plus 23 plus 40. Okay, simplify again. You will get 93 is equal to x plus 88, right? So your x is equal to 93 minus 88. X is equal to 5. So this is answer for number A. So you know that this is 5. So this region must be 10, 15, 18. This one, 7, 5, and 33. B, number of element in P. Where is P? Okay, this is your P. Number of element in P is equal to 15 plus 10 plus 5 plus 5 equal to 35. Similarly, for number C, number of element in Q, 10 plus 18 plus 5 plus 7 equal to 40, right? Number D, number of element in R, 5 plus 5 plus 7 plus 33 equal to 50. E, number of element P intersection Q. Okay, where is P intersection Q? P intersection Q must be this part. Okay, 10 plus 5 is equal to 15. Okay. F, number of element Q intersection R. Q and R, okay, 5 plus 7 equal to 12. G, number of element P intersection R, 10. H, so number of element R union Q, 78. Okay, you just have to sum up all this. Okay, 10, 18, 5, 7, 5, 33. Okay, then you will get 78. And the last one, number of element P intersection Q prime. Okay, what does this mean? Other than P intersection Q. P intersection Q is this area. So you have to sum up 15 plus 18 plus 5 plus 7 plus 33. So your answer will be 78. Okay. So I think that's all for today.